Hello viewers, welcome to this lesson, and in this tutorial I'm going to take you through the cosine rule. Before we do that, I'll be able to start with labeling of triangles because it's a concept that we shall be using later in the cosine rule. And so in mathematics we have a convention for labeling triangles. As you can see the figure below, ABCD. The side we have angle at A and angle at B and angle at C. So you find that angle A corresponds to the side that you've just seen there. And then we have the side B, small b, corresponding to angle at B, and then the angle at C gives us the side small c. Okay, so this means that the small letters A, B, C refer to the distances or the length, and capital letters A, B, C refers to angles. Now, we can have a look at this triangle. It just shows the same that about how angles can be labeled. So we have angle at D, and then we have the corresponding side is small letter d, and then we have E giving us small letter E, and finally the vertex F, or rather angle at F, gives us the side small letter f. So with that concept we can proceed to the cosine rule, and it is important to know that the cosine rule work for any triangle. So the cosine rule can be used with any triangle as long as we have been given enough information. Take an example of the triangle below, ABC. We are going to generate the cosine rule from this, and it's good we understand now that A corresponds to the side A and so on, and therefore that one will give us a formula which is now the rule, the cosine rule. A squared is equal to B squared plus C squared minus 2BC cosine of A. You will only understand this after we have derived the formula, and so that is what we are added to. Okay, so we shall start with deriving the rule, and that takes us to, we are going to use a triangle ABC, and of course with the triangle ABC has got corresponding sides A, B, C, small letters. So consider a general triangle ABC. We require A in terms of B, C, and A. So that means we are going to base our formula based on the side A in relation to the other sides B and C. So that means that first, this triangle we need to come up with a perpendicular height, and we are going to draw BP, which is perpendicular to AC, So that gives us the height of the triangle ABC, and it is perpendicular at point P. I mean it meets the base AC at point P, right angle, and therefore taking AC to be B, and we can say that we can give AP to be X. That means PC will be B minus X, because B is the total length, and therefore we can now find the height by using Pythagoras theorem, whereby BP squared, that is the height squared, is equal to, remember this height is a common height for the two triangles. We have now two triangles in this main triangle. So BP squared is equal to A squared minus this other side, the base, b minus x squared, and b minus x squared is in bracket. And so there is also, we can also find the other height of the other triangle, which is bp squared is equal to c squared minus x squared. I mean the triangle APB. So whatever answer that we have are corresponding heights. They are the height for the triangle. So that implies that we are going to equate, because it's a common height, so we equate what's the value for bp squared. So a squared minus b minus x then squared is equal to c squared minus x squared. And now b minus x squared we are going to expand. We shall expand to get b squared minus 2bx plus x squared. Now that gives us a squared minus into bracket b squared minus 2bx plus x squared, close the bracket, equal to the other length c squared minus x squared. Now that implies that a squared minus b squared plus 2bx minus x squared is equal to c squared minus x squared. So we have just collected the like terms together, having opened the bracket. And now that gives us a squared is equal to b squared plus c squared minus 2bx. Okay, but then we have it that since cosine of a is equal to x over c, so let's go back to the triangle, the angle at the angle A. So we have that when we use 𝐂𝐎𝐒, of course, whereby cosine of A is equal to adjacent over hypotenuse. So the adjacent to this is x, to angle A is x, hypotenuse is c. So cosine of A is equal to x over c. And that implies that we want now to get the value of x. The value of x, that will give us x is equal to c cosine of A. So we shall substitute it in the equation above. A squared equal to b squared plus c squared minus 2bx. So now that we have the value of x, we shall substitute it there, so that we have we finish our derivation on the rule. Therefore, we have it that a squared equal to b squared plus c squared minus 2bc cosine of A. So you realize that because we have taken into consideration the side A, now the cosine of the angle will be the angle at A. Now we are going to look at now some key issues on this rule. The cosine rule can be used to find. Now we want to now see areas or when cosine rule can be applied. So we have number one there, an unknown side when two sides of the triangle and the included angle are given, that is SAS. It's a property of congruency. And now number two, cosine rule can also be used to find an unknown angle when the three angles are given. We have that property as SSS, the three sides given, when the three sides given. And now that can take us to, let's try finding an unknown side, whereby if we can also come up with other formulas depending on the remaining sides, which is B and C. So we are going to apply the same method as earlier to the other sides, so that to produce a formulae for B and C. So we will now have it that if we choose side B, then it will go as B squared equal to A squared plus C squared minus 2AC cosine of B, because we chose side B. Also, if we pick side C, then it will go as C squared equal to A squared plus B squared minus 2AB cosine of C. So, depending on the triangle, you will use the sides given to come up with these formulas, and should be guided by, if you pick for a triangle ABC with the sides ABC, then if you pick A, then finally it's going to be cosine of A. If you pick B, finally it will be cosine of B. And if you pick C, the same happens. That one gives us the rule, the cosine rule in this case, given side A, side B, and side C. So this will be applied in any other triangle that has the three sides. Okay, let's now look at how to determine when to use the cosine rule. So we are going to look at some questions here. A cosine rule can be used to find length, and it depend on the triangle, because if you've been given the sides, then you'll be required to find the side, maybe if you have the corresponding angle, and so on. Number two, do you know two sides and the angle in between? That is, two sides and an included angle in between. I think the cosine rule can also be applied in that way, so that you find the sides, you find the side given an including angle. Now, I think these are the areas where you can apply the cosine rule. Otherwise, if you can't use the cosine rule in that particular triangle, then you will be able to, if it doesn't apply, then you will be able to have an option with the sine rule, which we did in our previous tutorial. And now we will now take some few examples on this. We shall start with finding length using the cosine rule. Remember, with the cosine rule, just like sine rule, we can find the length using the cosine rule. As well, we can find the angle given, or rather, using the cosine rule. So example number 1 says, find the unknown side in the triangle below. And the triangle, we have the sides given. We have one labeled 5 meter, the other one 12 meter, and the other one is labeled L, with an including angle 43 degrees. So the unknown side is the side labeled L. So we shall apply the cosine rule in this case, whereby in our case, if we choose to use A squared is equal to B squared plus C squared minus 2BC cosine of A, then A is going to be L, and then B is 5 meter, and then C is equal to 12 meter. Then our angle A degrees is equal to 43 degrees. And now, because we have the cosine rule, we're going to substitute the values to find a squared, because now we've been told to find the unknown side, which is L, and we have said from our formula A is equal to L, and therefore substituting will give us A squared is equal to 5 squared plus 12 squared minus 2 times 5 times 12 times cos 43 degrees. And if you work out these well, you will get that is 25 plus 144 minus 120 times this one will give us 0.731, 3 decimal places. And now you work out everything, you get A squared is equal to 81.28. So to find A, of course, we are going to get the square root. Get the square root of both sides. So that means we will get A to be 9.02 meter. And this means that the unknown side, which was L, now it will be 9.02 meter. And that is the solution of that triangle. Example number 2. Find the length of side M. Side M, we have been provided with a triangle with 2 sides with known length. So we have 12.2 meter. Another one is 17.5 meter and an included angle 137 degrees. We are required to find the length of the unknown side, which is M in this case. And of course we shall apply. We have it that in our formula A squared is equal to B squared plus C squared minus 2AB minus 2BC, cosine of A. And it's not a must that you use A squared. You can use even B squared is equal to or C squared, you see, but then you need to link it with the figures and length in the triangle. So we will take our A to be M and our B to be 12.2, C is going to be 17.5, and our A degrees be 137 degrees, because we want to use the formula, and our formula is A squared equal to B squared plus C squared minus 2BC cosine of A degrees. And therefore we do the substitution, and we get A squared is equal to 12.2 square plus 17.5 square minus into bracket 2 times 12.2 times 17.5 times cos 137. You work all this and you get A squared is equal to 455. You can do this using your calculator. 455.09 plus 312.17. Okay, and then my calculator gives me A squared equal to 767.227. And so to find the value of A, we do the square root of both sides. And so A, which was equivalent to M, or equated to be M, our M from the triangle is 27.7 meters, and that gives us the solution for the side of that triangle. Okay, we can take some assignment. Find the length of the unknown side in the triangles. Number 1, the triangle is given there, 2 sides provided, included angle, and then you're supposed to give a solution for the value of L. You do that, of course, if you do it properly, having followed all the information that we've gone through, you'll get an answer. L is equal to 47.5 centimeter. Number 2, we have the triangle which is 3 sides, 5.2 meter, we have 8 meter, and the side M, and included angle 38 degrees. If you do it well, you get this answer, which is M is equal to 5.05 meter. Okay, now let's find some worked examples on finding angles using the cosine rule. Now consider the rule again, and for this case we shall use a squared is equal to b squared plus c squared minus 2bc cosine of a. You can use the other formula on b and on c, but for this case let's work with a squared. And now we are going to change the subject of the formula to cosine of a. In other words, we make cosine of a the subject of the formula. Okay, now having b squared plus c squared minus 2bc cosine of a degrees is equal to a squared, we'll now take b squared and c squared across. Take b squared and c squared across, they cross the equal sign. So what will happen? We'll have 2 minus 2bc cosine of a degrees equal to a squared minus b squared minus c squared. So when a positive number crosses the equal sign, the sign changes. For this case, it was positive b squared and positive c squared cross the equal sign, and now we have minus b squared minus c squared. So that is what is happening there. Now we are left with 2bc. Now we want cosine of a degrees. We shall divide by minus 2bc both sides, and so we'll have cosine of a degrees equal to a squared minus b squared minus c squared over minus 2bc. And if we divide with negative a, divide by negative a, we shall have it cosine of a degrees equal to b squared minus plus c squared minus a squared over 2bc, and that will be the subject formula of cosine of a. Okay, now we shall be using this to find the angles using the cosine rule. We have just made it easier to be able to find for the angles in the solution, for the solution of this triangle given in example 1. And now calculate the unknown angle a degrees from the triangle given there with 3 sides, 9 meter, 11 meter, 16 meter. The other, it is the longest side there, with the corresponding angle a degrees to the side 11 meter. And so we have the formula. We want to find the angle a degrees, so we do the solution. So of course a is what we want, a degrees is what we want. We have our a, and we take a to be 11, b is 9, and c is 16 meter. From this we now substitute in the formula, and we have that cosine of a degrees is equal to 9 squared plus 16 squared minus 11 squared over 2 times 9 times 16. With your calculator, you can calculate for cosine of A degrees, and my calculator gives me 0.75. And so, of course, that is not what we wanted. We want the value of angle A degrees. That means we shall find cos inverse of the answer 0.75 to find A degrees, and that gives us that A degrees is 41.4 degrees, and that is the solution for the angle A degrees in the triangle above. Example number 2, find the angle Y degrees in the triangle. Same concept. We have the formula, and then we identify the side and angles. Our A degrees will be Y degrees, and our A is 26, B will be 15, and C equivalent to 13 centimeter. So we do the substitution, and we'll get cos A degrees equal to 15 square plus 13 square minus 26 square over 2 times 15 times 13. Now, from here, you use your calculator to find the value of cosine of A degrees, and my calculator gives me negative 0.723. But we still want the value of A. The negative tells you the angle is obtuse, and therefore cosine inverse of the value there is 136.3 degrees. Now, let's take some assignment on the same. Calculate the unknown angles in the triangle below. We have two questions, two triangles there. If you do the first one, you'll be able to get A degrees is equal to 111.8 degrees. Number 2 will give us the value of B degrees to be 37.3 degrees.